The main significance of the mean value theorem is that it enables us to obtain information about a function from information about its derivative. Our immediate use of this principle is to prove the basic facts concerning increasing and decreasing functions. Now, increasing and decreasing functions, back in section 1.1 we defined increasing functions and decreasing functions, and in section 2.8 we observed from graphs that a function with a positive derivative is increasing. We now deduce this fact from the mean value theorem. Increasing, decreasing test. Definition for A. Okay, if f prime of x, or the derivative, is greater than 0 on an interval, then we're going to say that f is increasing on that interval, meaning the function f is increasing on that interval. B, if f prime of x, or the derivative, is less than 0 on an interval, then we're going to say that the function is decreasing on that interval. So let's take a look at the proof for both A and B. So the proof for A, okay, so what we're going to do is, in step number 1, okay, we're going to let x1 and x2 be any numbers on the interval. Okay, so here is x1 and then x2, and we can see that x1 is less than x2 on the x-axis. Now, according to the definition of an increasing function, what we have to show is we need to show that f of x1, which is here, is less than f of x2. So that means this f of x2 needs to be greater than this f of x1. And so now, because we are given that f prime of x in part A is greater than 0, we know that the function f is differentiable on the interval between x1 and x2. So by the mean value theorem, there is a number c between x1 and x2, and such that f of x2 minus f of x1 is equal to f prime of c times x2 minus x1. Now, if we say that there's a value of c, okay, f prime of c is greater than 0, by assumption, and the fact that x2 minus x1, if we take x2 and we subtract x1, it's going to be a positive value, so it's going to be greater than 0. And because of the fact that x1 is less than x2. Thus, the right side of the equation 3 here is going to be positive. So that means that number times f prime of c is then going to tell us that f of x2 minus f of x1 is greater than 0, or f of x1 is less than f of x2. And so the reason for the or statement here is that if we subtracted f of x2 to the right side and divided by the negative, we flip the inequality, get f of x1, which is less than f of x2, and therefore this shows that it is increasing. And if you take a look at the graph here, here is the point of that curve. It's in between x1 and x2. And so from this point to this point, we can see that this tangent line is, the function is increasing. So let's take a look at proof B. Okay, and so for part B it says if f prime of x is less than 0, meaning that is the slope negative on an interval, then f is decreasing on that interval. Okay, so what we're going to do is, in proof part B, we're going to let, again, x1 and x2 be any two numbers on the interval. So here's 1 and x2, where x1 is less than x2. Okay, and now what we want to do is, according to the definition of a decreasing function, we have to show that f of x1, which is here, is greater than f of x2. So we can see here graphically, we can see the fact that f of x1 is going to be greater than f of x2. Okay, now, because we are given the fact that f prime of x is less than 0, we know that f is differentiable on the interval between x1 and x2. So by the mean value theorem, there is a number c between x1 and x2, okay, such that, equation 3, f of x2 minus f of x1 is equal to f prime of c times x2 minus x1. Now, f prime of c, according to our definition for proof B, is less than 0, meaning that it's negative. So if that's negative, and also by assumption the fact that x2 minus x1 is greater than 0, and because of the fact that x1 is less than x2. But because this is negative, then the right side of the equation is going to be negative because of the slope being negative. And so we can then say that f of x2 minus f of x1 is going to be less than 0. Because if we're taking the value of f of x2 and we subtract the value of f of x1, it's going to be negative. So we know it's going to be less than 0. Or we can say that f of x1 is greater than f of x2. And so therefore this shows that it is decreasing.